Number 5, we're looking at calculate the pH of a 1.60 ch3nh3cl solution. Kb for methylamine is that. So 3.7 times 10 to the negative 4. So this is question 4? Question 5, sorry. So this is I want the pH of 1.60 molars of a ch3nh3cl solution, and the Kb for methylamine. So Kb for ch3nh2 would be 3.7 times 10 to the negative 4. So basically how we want to form how we want to write this chemical reaction. So we're given this guy first, right? So we want to figure out the dissociation of this guy first. So we have CH3 NH3Cl, right? So this is going to dissociate into 2 ions. Again, it's going to be my CH3 NH3 plus Cl minus, right? It's going to dissociate if you put it in an aqueous solution here. And then finally, this here is now my methylamine, and this here will then react with water, right? CH3 NH3 plus water will be then in equilibrium, and I'm going to get here a CH3 or H3O plus first, and then an NH2, right? CH3NH2 is going to lose a hydrogen here. NH2, it's going to lose a hydrogen here. So this here is my equilibrium reaction, and then the Kb for CH3NH2 would be 3.7 times 10 to the negative 4. So they actually wrote the exact same thing here, which is great. But again, if I look at my kind of compound here, I'm forming H3O plus here, which is an acid here. So this here I would actually have my Ka here. So I have to actually solve for my Ka. So because I'm given a Kb, what I'm going to have to do is relate it to Kw, right? Because I know that Kw equals Ka times Kb. I know that Kw is 1.0 times 10 to the negative 14, which will equal Ka times 3.7 times 10 to the negative 4. We should make Ka would equal, I simply have to divide both sides by 3.7 times 10 to the negative 4, which will give me 2.703 times 10 to the negative 11. This will make Ka for my solution here. And what I can do now is I can write out my my formula, right? I have Ka here. It's going to equal, again, H3O plus, which is what I want to find out, times my CH3 NH2 times, all over, this is CH3 NH3 CH3 NH3 plus, and then all water here does not participate in my Ka reaction here. I know my pH of this solution here is 1.60, right? So this is actually going to fully dissociate into this ion here, which means I have 1.60 as my concentration here. I don't know these guys here, so what I can do is I can simply just use an ice table to figure out the equilibrium of this guy here. So I have my K expression, which is great. I'm going to have to do an ice table now. So let me draw out the ice table here. So I have, So again, I have CH3, and because I want to figure out my my things to plug into my K, right? So I have CH3 NH3 plus H2O. It's going to give me CH3 NH2 plus H3O plus. So again, ICE, initially I'm going to have, again, I have 1.60 molars of the solution here. I don't care about my water here, and this here I have 0 and 0. I'm going to subtract x, I'm going to add x on both sides here, and I'm going to have this and like so. I can substitute these guys into my K expression here. So let me rewrite the K expression as my variable. So obviously hydronium here is 8x here, methylamine is also x here, and we divide it by 1.60 times 10 to the negative x, and this will equal my Ka, which is what I solved for initially here, which is 2.703 times 10 to the negative 11. I'm going to approximate it and assume that this is much smaller. This x, I'm going to use a small x approximation here, so I can cross this out. So simply, I'm going to have x squared on the top, and I'm going to multiply both sides by 1.60 here to get 4.32 times 10 to the negative 11. And I'm going to square root both sides to get my x value here. So I'm going to square root this number. I'm going to get 6.576 times 10 to the negative 6 here. And this is going to be my x value here, which is my concentration of both my hydronium and CH3NH2. So this here would also become the concentration of my hydronium ion. I simply now just have to solve for that pH. So I know that pH equals negative log of my hydronium ion. pH is negative log of basically 6.576 times 10 to the negative 6 moles, because this is my concentration of my hydronium. I plug that into the calculator, and I would get a pH of 5.818 here, and this will be my solution for this question here. So 5.18 here is my solution, which is the correct solution that they have here. So the solution is correct. Again, the hydronium ion calculated that correctly as well. So the solution here is correct. Great analysis here.